Okay.
We good? So this is question 6 from the AP Calculus BC FRQ response from 2014. So it starts by giving you the Taylor series for a function f of x equals the sum from n equals 1 to infinity of negative 1 to the n plus 1, etc. And it converges to f of x for the absolute value of x minus 1 is less than r, where r is the radius of convergence. And so A is the first question and asks you to find r. So to find the radius of convergence for a function, usually you would use the ratio test. And in this case, you do as well. So for the ratio test, you take the limit as n approaches infinity of negative 1 to the n plus 1 plus 1. So to the n plus 2 times 2 to the n plus 1 over n plus 1 times x minus 1 to the n plus 1 all over the original equation, so n plus 1 to the n and x minus 1 to the n. So from here you simplify and you get rid of this and this n, you get rid of this and this n, get rid of this and this n plus 1, this goes down to 1, and then that's all we cancel. So you're left with the limit as n approaches infinity. That's a terrible word for me. A close one. Of negative 1, since it's just negative 1 to the 1, times 2 to the 1, times x minus 1 to the 1, over n plus 1 times n. And this is how it simplifies. So from here we can immediately take the limit. So from here we get the limit n approaches infinity of n over n plus 1 times negative 2 times x minus 1. And of course, just from knowing limits of infinity, one of the rules is that if the degree of the denominator and the degree of the numerator and the denominator is the same, it's just the division of these two constants, and since that's 1, this simplifies to 1. So you're left with you're left with negative 2 times x minus 1, and this is how you're supposed to find the radius of convergence. So since this is the ratio test, it's going to converge as long as x, the absolute value of x, which is this, is less than 1. Or if this is less than 1 and greater than negative 1. So now it's just as simple as solving the inequality. So you get negative 1 is less than negative 2x plus 2 is less than 1, so you minus 2 from all sides and you divide by negative 2. Of course, when you divide by negative, you switch the direction of the inequality. So you get 3 halves is less than x is less than 1 half. So if x is centered around 1, then the radius of convergence is, of course, 1 half. So the answer to this question is r equals 1 half. Alright, the next part of the question is it asks you to find the first 3 non-zero terms and a general term for the Taylor series of f prime, the derivative of f about x equals 1. So f is just this about x equals 1, so we need to find the first 3 terms of this up here. And then it's as simple as taking the derivative from there. So the first term of that is when n equals 1, it's positive 2 to the n over 1, 2 to the 1 over 1, so 2 times x minus 1, 2 to the 1. In the next term, it's negative because it's 2 plus 1, which is 3, which is an odd number, times 2 squared over 2, which is 4 over 2. And I'm going to leave it unsimplified for now. Times x minus 1 squared. And then the third term will be once again positive negative 2 to the 3, which is 8 over 3 times x minus 1 cubed. So this equals f of x when you go out 3 terms. So if you're trying to find f prime of x, you would just take the derivative of this like you would any other equation. So using the chain rule, for this we just get 2. Minus, bring down the 2 and you get rid of it. So 4 times x minus 1. And that's why I didn't simplify that. The 3 comes down. X minus 1 squared. And these are the first 3 terms of your f prime. So immediately we've got one part of the answer. But then it asks to find the general term. So essentially, you should be finding the nth term, or a general equation for it. And so I'm going to give my answer in the form of essentially this, but with the derivative. So, by looking at the equation you just made, and taking it from n to infinity, you can find it similar to that equation for the sum. And you get negative 1 to the n plus 1, since it still switches at the same side. And that could also be n minus 1 times 2 to the n, because it goes up in the squares, not squares, powers, times x minus 1 to the n minus 1, because at n equals 1 we have done, and then it keeps going. So this is the answer, and the end of that part of the question. So C asks you to find. C says the Taylor series for f prime about x equals 1, found in part B, which is essentially what we have here, is a geometric series. Find f prime to which the series converges for x minus 1 is less than r, and then use this function to determine f for x minus 1 is less than r. So for any geometric series, it's going to look like this. N equals 1 to infinity of a r squared. And the way you solve this is that if it will converge if r is less than 1, and it will converge to a over 1 minus r. And these are just the rules for geometric series. So in order to get this into this form, we need everything in, but not squared, sorry, n minus 1. In order to get this form to this form, we'll just use some algebra. So negative 1 times negative 1 times negative 1 to the n minus 2 plus 1, which is just essentially n minus 1, which is the form we wanted, times 2 to the 1, 2 to the n minus 1, x minus 1 to the n minus 1. So since we have all these nice powers that are multiplied together, these three can become negative 2 times x minus 1 to the n minus 1, and this is still the sum, by the way. So if we simplify this down, this just becomes positive, so it's the sum from n equals 1 to infinity of positive 2 times negative 2x plus 2 to the n minus 1, I believe. Yes. And so now, since we have our geometric series, we can find all of the x values for which this converges. So if we just plug it into this equation, we have our a equals 2 and r equals 2x plus, negative 2x plus 2, or 2 minus 2x. So that would be 2 over 1 minus 2 minus 2x. So from this we get 2 over 2x minus 1. And this is the x value for which, the x values for which f prime of x converges, because it is a geometric series. And so, if we're trying to find when the original equation converges, since that is f of x, if we take the integral of this, we'll get back to that and find when that converges. So if we take the integral of this, and I'm going to bring it up here, f of x equals the integral of the integral of 2 over 2x minus 1 dx. And this is just a simple matter of u substitution. So u equals 2x minus 1 du equals 2 dx. So this becomes the integral of 1 over u du, which of course is the natural log of u. So f of x equals the natural log of u, and therefore, since u equals 2x minus 1, f of x equals the natural log of 2x minus 1, and that